Well, hello, welcome class. This is lesson 3.1, and as you can see from the opening screen, we're going to be talking about divisibility and how you can use that for mental math. And this video is going to feature myself and my good friend.
I'm Mrs. Clark.
And we are going to talk about the different divisibility rules you need to know. So, strap on your seatbelts, here we go. These are the main rules, 2, 3, 5, 9, and 10. Okay, so Clark, let's help him out here a little bit. When is a number divisible by 2? If you look at a number and it's what?
Even.
Right. So all even numbers are divisible by 2. That's all you got to do. And the easy way to tell if something's even is just look at the last digit. If it's a 2, 4, 6, 8, or 0, it's even. That's it. All right. Now, actually, even easier than that is the 10 rule. Something is divisible by 10 only if it ends in what?
A 0.
Right. It has to end in a 0. Absolutely no other choice. Okay? And then the next easiest rule, I would argue, is the 5 rule. And a 5 rule, again, all we have to do is look at the last digit, and if it ends in a
0 or a 5.
A 0 or a 5, then it's divisible by 5. If it ends with anything else, it's not divisible by 5. All right, so if it's even, which again is an end rule. So notice all of these rules, 2, 5, and 10, all we got to do is look at the last digit, whatever it ends with. So it ends with an even digit, then the number is even and it's divisible by 2. If it ends in a 0 or 5, like 15 or 20, then it's divisible by 5. If it ends in a 0, it's divisible by 10. All right, the next easiest rule, I would say, is probably the 3 rule. Although, what's similar about the 3 and the 9 rule, everybody, is you do the same thing. So for the 3 and the 9 rule, what you're going to do is you're going to add up all the digits in the number. Sorry, I had to close the door. But anyway, so the 3 and the 9 rule both start out the same way. So let's actually take an example. Let's take a number like 78. All right. And so for the 3 or the 9 rule, what do we do first?
First, we add up the digits.
Right. So 78. Don't worry about place value. It's a 7 and an 8. So if you add 7 plus 8, you get 15. Now, just test this number. That's a lot easier than 78. And if that number right here, the 15, is divisible by either 3 or by 9, boy, my stylus isn't working today, then so is the original number. Okay, so 78 would be divisible by 3, but not by 9, because 9, so 3 goes into 15, but 9 does not. Okay, so for both of these, the 3 and the 9, you're going to add the digits, and you're going to test the sum. Okay, you test the sum of the digits. And if 3 divides it, then so does then 3 divides the original number. Okay? So for the 9 rule, you do the same thing, and again you test the sum. Okay, so let's try another example. Let's try 198. Okay? So add up the sum of the digits, 1 plus 9 plus 8, and we get
18.
Now 18 is divisible by both 3 and 9, so is 198. And it turns out if you divide 198 by 9, I believe you get 22. And if you divide 198 by 3, you get 66. So it's evenly divisible. And so actually, I guess we should have probably backed up for a second. So what we mean by divisibility rules is these are the rules for whether or not these numbers 2, 3, 5, 9, or 10 will go evenly into the number, divided exactly with no remainder. Okay? So obviously if I take an even number and I divide it by 2, I'll get a whole number. Okay? So that's what we mean by divisibility, when we can divide a number out and we still get another integer. All right, so now these are the ones that you're going to mostly need to know for this lesson, this chapter. These are the ones that will actually be on the quizzes and the test. But since we're talking about divisibility rules, let's do some other ones. So 2, 3, 5, 9, and 10 are the main ones, and they're honestly probably the easiest ones. Again, remember for 2, 5, and 10, all we had to look at is what?
The last number.
Yeah, you literally just look at the last digit. That's all you got to do for these three. So that's actually really quick. That shouldn't take any time at all. And for 3 and 9, you do the same thing. You add up the digits and you test them. Okay. So now let's talk about some other rules. There are actually rules for 4, 6, 8, and 1. Now I threw 1 in just kind of to be silly. 1 is actually probably the easiest rule. All right. So 1 is pretty basic because if you divide anything by 1, it works. So there really isn't a 1 rule because it just always works. Everything is divisible by 1. Okay, but there are rules for 4, 6, and 8. And the rule for 4, there's 2 of them. What I like to do, if it's a small number, what I do is I just take half the number. First of all, it's got to be even. For all 4, 6, and 8, those are all even numbers. So if you have a number like 53, there's no sense even testing it. Okay, but if you have an even number, the way to tell whether something is divisible by 4 is you just take half of it. So if I took a number like 46, and I take half of that, I get 23. Well, if it stays even, then it's divisible by 4. If it doesn't stay even, if it changes into odd, like 46 did, to 23, then it's not divisible by 4. And so that's what I do for divisible by 4. But if it's a really, really super long number, like let's say it was 54,736, or I guess we were doing 46 here, 46, then all I got to do is look at the last 2 numbers. And again, the same thing. Just test the last 2 numbers. If I take half of that, I get 23. If it stays even, then the number is divisible by 4. And if the last 2 digits are divisible by 4, so is the whole rest of the number. Okay, the 8 rule is very similar to that, but for the 8 rule, I have to test the last 3 digits. So if the last 3 digits are divisible by 8, so is the whole number. So for the 8, you got to do the half thing, but this time instead of doing it twice, you have to do it 3 times. So you take half of 746, and you get 273, and as soon as you get an odd number, you're done. So the only way something's going to be divisible by 8 is you take half of it and get an even number, and then take half of it again and get an even number. Actually, I guess you only have to do it twice. Okay, so that's the divisible by 8 rule. So you can look at the last 3 digits, and you can do the even rule. Now the 6 rule is my favorite, and that's Clark's going to tell you about that. So if you have a number like 6 or 14 or something like that, instead of testing whether or not it's divisible by 6, what numbers make up 6?
2 and 3.
Right, so if I take 2 and 3, and I just go back to the rules from the previous screen, the 2 rule said all you got to do is check and make sure it's even, and the 3 rule means I add up the digits and see if the sum is divisible by 3. So if I try both of those rules and they both work, since 6 is equal to 2 times 3, that'll tell me if it's divisible by 6. So a great example, suppose I have, I don't know, say 42. All right, 42 is even, so it's divisible by 2. That's a check. And 42 adds up to 6, and that's divisible by 3, so that's a check. And therefore, not only is 42 divisible by both 2 and 3, it's also divisible by 6. Okay? And if you have a bigger number, you do the same thing. And that is the 6 rule. A similar rule like that, if we knew a 7 rule, then 2 times 7 would give us a 14 rule. And technically, if you think about it, that very first rule we had, the 10 rule, well, look at the 2 and the 5 rule. 2 times 5 equals 10, right? What did the 2 and the 5 rule say? Well, for the 2 rule to work, it had to be even, and for the 5 rule to work, it had to end in a 0 or 5. So the only possible way that both the 5 and the 2 rule work at the same time is if it ends in a 0, because 5 is odd. So there you go. So it even technically was one of the rules on this screen. All right, which begs the question, are there still more divisibility rules? Well, there are. There's actually a divisibility rule. If you go online, Clark and I just did this. If you go and you look up on like Wikipedia, you can do divisibility rules for like all the numbers from 1 up to 20. And some of them even have like multiple rules, like the rules we were just talking about with 4 and 8, where there's more than one way to do it. I'm going to show you one more because I just think it's really cool, and that's the divisible by, well, I'm going to show you both of these, I guess. The divisible by 7 and the divisible by 13. But before I do, Clark's got to take off, so she's going to say goodbye, guys.
Goodbye.
And you'll see her around school another time, but thanks for coming in.
Thank you.
All right, take care.
Thanks.
All right, let's get back to work and wrap this up. Okay, so let's take the 7 rule. Here's how it works. So let's just make up a number. I don't know, let's start with 91. Okay, here's how you do it. You take the back number off and you literally rip it right off. So now I'm left with just plain old 9. And you take this number and you multiply it times 2. So 1 times 2 is 2. Then you bring it back to what was left of the original number. So really it's the tens digit, and you subtract it. So 9 minus 2 gives me 7. And if this number here that I get is divisible by 7, then so is the original number 91. And it turns out that 7 did go into 91. It went in exactly 13 times. All right, let's try another one. All right, so 246. So again, take the last digit completely off, rip it off, double it, you'll get 12. And put it down here and subtract, and I get a difference of 12. Now, does 7 go into 12? The answer is much easier to test than whether or not 12 goes into 246. And so the answer is no. 7 doesn't divide 12 evenly, so it didn't divide 246 evenly either. Okay? All right, well, let's change the number. What if it was 266? Same thing. Let's take the 6 off, double it. We're going to get 12. Now subtract, and I get 14. And 7 does divide 14, so that means that 7 also divides 266. So, you're not going to be responsible for this rule on a quiz or a test or anything. I just thought it'd be fun to show it to you that there are some crazy rules. Now, you could argue, and a lot of people do, if you just take 266, isn't it easier just to divide it by 7 and see if it works? Let's see, 7 goes into 26 3 times, you get 21, you get 56, and 7 goes into 56 8 times, and so the answer is yes, it worked. Because I get 56 and I get no remainder. And in all honesty, with the 7 rule, you could argue that just divide the stupid thing is almost easier. It's certainly easier if you get to use a calculator. So you could always just do that. Just try dividing by the number and see if it works. But there is actually a trick for 7. And you can see that if the number was really big, the trick might be easier than doing the division. Okay. Now, if the trick is applied and you get a big number down here, let's say it wasn't 14 and you can't tell, let's say it was still 142 or something, you can always do the trick again to find out if this number is divisible by 7. So you can keep applying it until you get a really easy one that you can do in your head. The 13 trick, let me switch colors here, is very similar. If I took a number like 91 and I wanted to see if that number was divisible by 13, again, I do the same thing. I take the last digit off, I rip it off, except this time, instead of multiplying by 2, I multiply by 4. So 1 times 4 is just 4, and this time, instead of subtracting, I add. So 9 plus 4 is 13. Oh, look at that. 13 goes into 13, obviously, one time, so that means that 13 also goes into 91. And of course it does, because we just did that a second ago. 7 times 13 is equal to 91. So actually 91 was divisible by both of the numbers on the screen, both 7 and 13. Okay. Let's try the other one that we just had, 246. Let's see if that was divisible by 13. Okay. And so I'll take 246, and I'll take the 6 off, and I don't have a lot of room here, so I'm going to do this one kind of a little bit more in my head. If I take 6 off, 6 times 4 is 24. I add it to the 24, I get 48, and I ask myself, does 13 go into 48? And it does not. It goes into 39, and it goes into 52. So the answer is no, so 13 did not divide 246. If I try it on the next one, 266, again, take 6 off, multiply by 4 this time, and you get 50. Close, but no cigar. But if I did 286, 286 would work. Because you take the 6 off, you multiply by 4, you'd multiply 20, or you'd add 28 and 24, and you would get 52, and 52 is divisible by 13. And the quick way to tell that is there are 52 cards in a deck of cards, because there are 4 suits with 13 cards each. So 4 times 13 does give us 52. All right. So there's the divisibility rules. All right. So to wrap this up, because it's getting a little long, what I'd like you to do is pause the video, and I want you to take these 5 numbers, and what I'd like you to do is after each number, I just want you to write down the numbers from the main ones, the 2, the 3, the 5, the 9, or the 10. Write down any numbers that divide these numbers. And I'll do the first one for you. So let's look at 837. So we look at the last digit, Okay, the last digit is a 7, so you don't have to write all these out, but we're going to test it for 2, 3, 5, 9, and 10. Okay, well, it's an odd number, so 2 doesn't work. It doesn't end in a 0, 5, so 5 doesn't work, and it didn't end in a 0, so 10 didn't work. So to test the 3 and the 9 rule, what do I have to do? I have to add up the digits. So what does 8 plus 3 plus 7 equal? Well, if I start at the back, what's 3 plus 7? 10 plus 8 is 18. And 18 is divisible by both 3 and 9, so that would be my answer. I would just write down 3, 9, and those are the numbers that of my list, 2, 3, 5, 9, and 10, that work, that go into it. So you can show your work either way. You could write out all 5 numbers and then just cross out the ones that don't work, or you could save yourself a little trouble and just do the tests and then see which one works. So what I'd like you to do right now is pause the video, finish these last 4 questions, exactly 4. That's a good thing to remember for the quiz tomorrow. And as soon as you're done writing down which of these 5 factors go into the rest of the numbers, resume the recording and see if you're right. Okay, pause the video now. All right, so you should have stopped and done all 3 of these numbers. So let's look at the next one. Number 2, 842 ends with an even number. Okay, so right away 2 goes in. Okay, it does not end in a 0 or a 5, so we don't even have to worry about 5 and 10. They're out. But I do need to add up the digits. 8 and 2, I'm going to put those together first because that adds up to 10, and 10 plus 4 is 14. Now, is 14 divisible by either 3 or 9? 14 is not, so that's the answer. 2 is the only one of those 5 factors that goes in. 621 also ends in an odd number like the first one did, so 2, 5, and 10 are all out. Well, I guess odd number doesn't mean 5 of that. Okay, so it ends in an odd number, so 2 is out. It doesn't end in a 0, so 10 is out. And it doesn't end in a 0, 5, so 5 is out. So just by looking at the last digit, I can take care of the 2, the 5, and the 10. If I add it up, it adds up to exactly 9. The digits do 6 plus 2 plus 1. So 9 is divisible by both 3 and 9. So those are my factors. Number 4 ends in a 0. So automatically, I don't even have to think about this, 2, 5, and 10 work. Why? Because it ended in a 0. The 0, it ends in a 0. That means the 10 works. It ends in a 0 or 5, so 5 works. And it ends in a 0, which is even, so 2 works. So all 3 of those work this time. Now, if you add up 1,110, just add up the digits. 1 plus 1 plus 1 adds up to 3. And 3 is also divisible by 3. So 3 goes in too. But 9 does not evenly divide 3, so that does not work. So the first 4 work for that one. And finally, number 91, it ends in a 1, so it's not even, so 2's out. It doesn't end in a 0 or 5, so 5's out. And it doesn't end in a 0, so 10's out. If I add 9 plus 1, I get 10, which means 3 and 9 are out, so I'm going to write, for this one, none. None of those 5 numbers go into 91. Okay? Now you might think 91 is prime, but it is not. As you saw on the previous slide, 91 is actually 7 times 13. Okay? That's, again, where those weird divisibility rules can actually be kind of helpful. All right, so to wrap this up, remember the main rules are for 2, 5, and 10, just look at the last digit. Okay? And the other 2 that we need to be concerned with are 3 and 9, and for that you're going to look at the sum of all the digits, and you're going to test that to see if 3 or 9 go into it. And that's it. All right, so I'm going to sign off, and thanks for watching, and I'll see you in class tomorrow. Bye.